In this lesson, we will learn how to perform the hypothesis test for the population mean using t-test, specifically using the TI-84 t-test feature. Heights were measured for a random sample of 17 plants grown while being treated with a particular nutrient. The sample mean and sample standard deviation of those height measurements were 37 centimeters and 12 centimeters, respectively. Assume that population of heights of treated plants is normally distributed with mean mu. Based on the sample, can it be concluded that mu is different from 40 centimeters? Use the 0.05 level of significance. Perform a two-tailed test, then fill in the table below. Carry your intermediate computations to at least 3 decimal places and round your answers as specified in the table. First of all, let's state what we know, what is given to us. We know that the sample size is 17, sample mean is 37, sample standard deviation is 12, the population from which this sample is drawn is normal, and alpha is requested to be at 0.05 level of significance. Please note that the sample size is quite small, so the statement that the population from which this sample comes from is normal is essential. Without this normality, we cannot proceed with this test. Now, one of the critical decisions you will have to make is whether you're going to do the test statistic Z or test statistic T, because these are the two choices whenever you are testing regarding the mean mu. Well, this time it will be T. How do I know? Because there's no sign of sigma. Nobody tells me what the population standard deviation is. And remember, if you don't know sigma, Z is not an option. But T is an option, even if when small size of a sample is, as soon as the population is normal and S is provided, we can perform the t-test. Hypothesis statement will be determined by the content of the story. We would like to know whether mu is different from 40 centimeters. That is the key word that tells me the alternative hypothesis will be mu is not equal to 40. Therefore, the null hypothesis must be the opposite statement, mu is 40. We already talked about the fact that test statistic will be T. Now we need to compute the test statistic. I'm going to use TI-84 to do all the computations for me. To perform this test, first of all, I state hypothesis. Then I state my alpha level of 5%. Then I go to the second option in the test menu to choose t-test and enter the information I have. I will show that on the next slide. Once I identify the t-value of -1.031 and p-value of 0.318, all I need to do is compare the p-value to the alpha level of significance of 500th. Because p-value of 0.318 is not less than or equal to 0.05, I cannot conclude that null hypothesis should be rejected. In fact, I'm gonna say as a conclusion, don't reject H sub 0. What does it mean visually? I would like to show you what it means. So we have a two-tailed test with alpha of 5%, which means 2.5% of area is in the left tail and 2.5% of area is in the right tail, and these are two rejection regions. My t-value is -1.031, so it's to the left of 0. But the amount of area to the left of that t-value is this much. It's almost 32%. That's a lot of area. So I'm going to indicate this right here. So I don't know, at 30%, it's about this far maybe. So all of this area is approximately 0.318. And this location is the t-value that separates the this amount of area from the rest of it. So this is -1.031. Please notice this test statistic is nowhere near the rejection region, which starts over here. And I don't really need to know what that critical value is. All I know is that p-value, the amount of area to the left of -1.031, is way bigger than the 5% of significance level we have. Therefore, we don't have evidence against the null hypothesis. We conclude there is not enough evidence at alpha equals to 0.05 significance level that the population mean height differs from 40 centimeters. Now, as I promised, I would like to show you how we perform this test using TI-84. Again, notice I just transferred the information I have to make sure it's handy when I enter things into my calculator. And we are going to do the following. Go to Stat, Tests, choose second option T-test, and enter the data you have. Mu sub 0 is 40. That's the number involved in the hypothesis statements. X bar is 37. Sample standard deviation S is 12. Sample size is 17. It's a two-tailed test, so not equal to is the right choice. Scroll down to calculate and press enter. As you can see, the numbers we get when rounding these t and p values to 3 decimal places are exactly the same as I showed you on the previous page. This is how I found them. I found them using TI-84. Therefore, using TI-84 functions embedded into your calculator is an easy and quick way of performing any hypothesis tests. Let's do one more example. A rental agent claims that the mean monthly rent mu for apartments on the east side of town is less than $750. A random sample of 11 monthly rents for apartments on the east side has a mean of $747. With a standard deviation of $16. If we assume that the monthly rents for apartments on the east side are normally distributed, is there enough evidence to conclude at the 0.05 level of significance that mu is less than $750? Perform a one-tailed test, then fill in the table below. Carry your intermediate computations to at least 3 decimal places and round your answers as specified in the table. First of all, let's quickly identify the information we are provided. We know the sample size is 11, sample mean is 747, sample standard deviation is 16, and alpha is 500th. From the sample size 11, we can find degrees of freedom by using the formula n minus 1. Anytime you have degrees of freedom, you just subtract 1 from the sample to get that quantity. So in this case, it is 10. Now it's time to look at the hypothesis statements. Notice that the claim we're trying to find evidence for says that the monthly rent mu is less than $750. So that's my alternative statement. Mu is less than 750. My null hypothesis has to take the opposite direction. Mu is greater than or equal to 750. So I record my alternative and null hypothesis right here. Alpha stated. Then I go into t-test and enter this information that I have and compare it to 750 as my mu sub 0. And t-test on TI-84 will produce t-value, the test statistic, at negative 0.622 and p-value of 0.274. If ALEKS was asking us for the p-value approach, like on the previous example we just did, I would have to just find these two numbers, compare p-value to alpha, and I could make my decision regarding my hypothesis statements. But ALEKS is asking for the critical value approach, so we need to do one more step. We need to compute the critical value at this significance level of 5%. Critical value t sub 0.95. Why this subscript? Because it's this location that separates 95% to the right of that point from 5% to the left of that point. Will be computed by inverse t. Please pay attention, don't use inverse norm by accident here. And inverse t function always asks you for the amount of area to the left of the t value you're trying to find, and there is 5%, and it asks you for the degrees of freedom. When you enter this into a calculator, you will get negative 1.812. What I found is that this location is negative 1.812, and I already know the test statistic of negative 0.622, which is somewhere there, definitely to the right of this critical value. Therefore, negative 0.622 happens to be in the acceptance region, well in the acceptance region. Therefore, we're not going to reject the null hypothesis. I'm concluding that at the 0.05 level of significance, there is not enough evidence that the mean monthly rent for apartments on the east side is less than $750.